Hello guys, welcome back to my channel InfoSec Lab, and today is going to be another video of attacking and defending AWS services. In today's room, we're going over AWS IAM enumeration, which is a very fun topic to go over with. Before we get into any materials of this room, there are some prerequisites for this room. Before starting this room, it's beneficial to have an introductory knowledge of identity and access management, or IAM, in AWS account. And users or you should understand how to assume row trust policy works. If you are not familiar with this topic, then please visit the AWS IAM room for more information. The learning objectives of this room is that knowing how to get information about AWS IAM resources without authenticating is an important skill for vulnerability assessments and penetration testing. In this room, you will learn how to perform an IAM Principal enumerations and partial service enumeration for AWS environments. You will learn how IAM resource policies can be abused to identify valid IAM principles, how to use open source tools to efficiently enumerate valid principles in a given AWS account, and last but not least, how to footprint potential services, including security services enabled for an account. Remember, these IAM principles form the backbone of access in AWS. Without them, there's almost nothing you can do. By being able to identify what valid principles exist in another AWS account, you form a basics of information to perform more well-informed attacks that are more likely to succeed. It is possible to get information about IAM principles from a target account and other insider information about an account while remaining unauthenticated to that account. This is referred to as an authenticated IAM enumeration. IAM enumeration is a reconnaissance exercise that can be leveraged to attack an AWS cloud environment. And by using this technique, an attacker can get a better understanding of the IAM landscape within an account without having access to it. AWS pen testers and red teamers commonly use this gathered inside knowledge to gain information about the resources residing within an AWS environment in order to perform attack against the target account. Alright, can you get information about an AWS account, including its IAM principles, without authenticating? Yes, you can. Assessing environment. Again, this is something that you should be able to do on your own based on the instructions provided here. Because of the sensitivity that I cannot perform this task, otherwise I'll be showing you my credentials, which is not a very good practice. So I'm gonna skip this one. Moving on, AWS IAM enumeration mechanics. Scavenging for credentials. You may find yourself in the machines and think, hey, I wonder if there's any AWS loot here. Let's take a look at how you might enumerate AWS principles and credentials in use on a machine you have compromised. AWS Boto 3 Python SDK is one of the most mature tools out there for working with AWS APIs. Excuse me. Therefore, we look to Boto 3 documentation to see how Boto 3 looks for credentials when running AWS commands to learn where credentials might be stored. Reading through the documents, a few places stand out. Environment variables. User can get set credentials using AWS access key ID and the AWS secret access key as environment variables. Remember, in this previous room, we kind of sometimes we configure our AWS credentials by using export and then AWS access key ID, and then we provide the value. Those are environment variables. Okay. Moving on, share credential file, which located at .aws/credentials folder. This is the most common place when storing IAM user access key or SSO configurations for assuming roles. So usually when you run the AWS configure command, and then after you provide the access key and secret access key, all the credentials are going to be stored in this location right here. Okay, AWS config file. Credential sources that reference helper scripts and other external credentials provider are commonly referenced here. So this is another place to look for the profiles or different profiles of AWS accounts. As you may know that when you work on different AWS projects, you might need different set of credentials to log in for those projects. And if you're only using one machine, then on your machine there has to be definitely be a lot of AWS profiles, and this is where you can find all the profiles available on the machines. Assume role provider. The trick here is to know that when someone uses AWS SSO or another mechanism to assume a role via the AWS CLI, the AWS CLI tool catches credentials for each role section at this folder. Okay. So this is also another location on the target machine to look for credentials. Bodo config file. Bodo 2 is the predecessor version to Bodo 3 and might be used for legacy clients. Instant meta service, IMDS. On Amazon EC2 instance that has an IAM role configure. We have already covered this one in the attacking and defending EC2 instances. So if you kind of forget or if you're not familiar with that, we can go back to that video and take a look at it. Okay. Why Bodo 3 checks for credentials stored in the metadata by endpoint. AWS Elastic Container Service or ECS tasks also have a metadata endpoint at 169.254.170.2. AWS Lambda store credentials as environment variables, and Cloud Shell store credentials via localhost metadata endpoint. If you find yourself on a compromised system, or any of these are potential sources of temporary credentials with varying levels of privileges. Let's get started by logging into your AWS Cloud Shell or your attack box with your AWS credentials. Cool. Okay, so I have already configured my AWS account on this attack box. So I'm not going let's get started. Get the access key info. If you have found an access key during your local system discovery process, you probably have a few questions, starting with what account does it belong to? The AWS CLI can help with this exact need without being authenticated to the target account. Okay, so we can use this command AWS SDS and then get access key info, and then access key ID is going to be. Now I'm going to be using the access key that I'm provided by TryHackMe. In this case, it's going to be this. Running this command should return the AWS account to which the access key belongs to. Interestingly enough, you can perform this command unauthenticate, meaning that you have explicit permissions to access this API by the default in AWS. This can help provide important context regarding the account you have how you have compromised in conjunction with the account alias, along with IAM and other resource naming or tagging conventions. Go ahead and try it with your access key ID. Okay, this is the account number. Let's write it down. We might need it in the future. Resource-based policy. As we discussed back in the AWS basic room, AWS resource-based policy are IAM policies applied directly to a certain types of AWS resources. Interestingly enough, these resource-based policies have little code that allows the attacker to identify any valid IAM principal in any given AWS account, and even the validity of any particular AWS account ID. Resource-based policies are comprised of the following format. Got a statement, we got statement ID, we got the effect, either allow or deny, the principles, and the action, and then the resource to act on. When attempting to enumerate an IAM principal via the resource policy, you simply create a resource that supports a resource-based policy and then update it to allow access for the principles you want to test whether it exists. If the principal does not exist, the update command will return an error message. If the principal does exist, then you will not receive an error message, and the updated resource policy will be implemented. For most type of the resource-based policy, this consists of the account IDs, IAM roles, and IAM users. Other types of principals aren't enumerable using this method. So answer the question. If an IAM principal does not exist, what does an attempt to update a resource-based policy to include in the principal return? It's going to error message. Okay, moving on. Enumerating IAM users and roles. In order to perform enumeration, we'll be using a tool called QuietRat. QuietRat can be used for unauthenticated enumerations of AWS, Azure Active Directory, or Google Workspace users principals. The reason I use coded around unauthenticated is because even though you don't have to be authenticated against the target you intend on scanning, for QuietRat to work, you do need to be authenticated to an account with permissions to deploy resources that QuietRat will be using to scanning. You can view the source code here on the GitHub, okay, which is right here. If you are using an attack box to work on the room, then you are already familiar with using AWS CLI tools and using AWS Configure to configure your credentials. If you have been using Cloud Shell, this may be your first time loading credentials. Because Cloud Shell relies on AWS metadata service to retrieve and use credentials, you won't find any credentials configured in AWS Cloud Shell if you try to navigate to this folder when you start up. This may be a problem when using the tools that default to using the default credential profile commonly implemented with AWS CLI. But in this case, we should be fine because QuietRat doesn't really care about that. Once you have credentials configured, if using Cloud Shell, you will want to install the QuietRat. You can do so by running the following command. Now, because I'm on the attack box environment, it's already been installed by TryHackMe, so we should be good for now. You can test that QuietRat is properly installed by running the following command: QuietRat help. Now, this shows that QuietRat has been installed on this virtual machine and is ready to be used. Before doing that, let me extend my machine. Okay, let's do it first. Okay, with that. Now, you will want to use QuietRat to scan your target account for potential users and roles. During S3 and API gateway rooms, you will note that the best cloud company appears to have 2 employees with the names Adam and John. Assuming Adam and John are technology employees with access to AWS, we could attempt to look for their users by creating a word list of potential usernames using common patterns employed by companies and common family names in the USA, where best cloud company appears to be the best. Assuming you have the family names stored in your local directory right here, you could use something like the following script to generate a list of common Adam and John usernames. Okay, let's try this. So let's copy the script first. So nano enumerate usernames.py. Paste control. Yes. Okay, we're going to look for this one, username.text right here. Copy. I believe it's in the sec list. I guess here. Share word list. Yes. I think it's sec list, okay. Usernames. It's going to be names. Oh, right here. family name top USA top 1000. This is the one we want to look for. We are looking for. So let's just copy that file to the current directory. No. Family name, okay, and then to the current directory. Okay, so we do have family names USA top. Okay, hold on a second, let me make a folder for this one. Like the IAM enumeration, and then I'm gonna move this one enumerate user to IAM to this folder, move this family to this folder too. Okay, so these are going to be the two files that we need to run the scripts. Now this is the file to be included in this script right here. So basically what the script does is using these two first name Adam and John and go through the list of the top common last names and append them with different formats. So depending on the organizations or company you work for, the username for your email is a little bit different. For example, if your first name is Adam and if your last name is Smith, you can have different combinations of first name and last name as your company's email. It can be adam.smith@bestcloudcompany.org, or it can be let me copy paste, or it can be a.smith, or it can be adam.s, or it can be a smith, and so on and so on. So basically with only first name and last name, you can have different combinations on the naming conventions of the email. And since we don't know what naming conventions of Best Cloud Company are using, we have to run the script. If by chance during our reconnaissance phase we get a hold of the email address of some employees from Best Cloud Company, then we know the format, then it's going to be easier for us, Okay, and let's try running the script. So Python 3 and then enumerate. So in the script right here, I'll put everything into the test.text right here. Test.text. We see that everything is created. We see a long list of usernames, and alright. So we have that. Let's continue to the quiet red. Now, but I've also included a pre-generated list common usernames in the names of Adam and John. So you may use them yourself with a quiet red. Well, since we have already generated the list right here, we don't actually need this one. They're the same. Once you have the username, save as usernames.text. In your machine of choice. Okay, so we'll test usernames.text. Now we run quiet red. Then you'll be select option 1 or 2, option 2, depending on wherever you want to scan for roles or users. Roles are the more common pattern recently, but a lot of organizations are still deploying IAM users. Let's start with the roles. So we start with the roles. It's going to be number 1, if I'm not mistaken. Yes. And then provide an account ID to scan against. Now, how do we get this one? Remember in the previous room, the way to get it is to run this command AWS SDS and then get caller identity. This is like the command who am I on Linux system. Okay, so we got account number, copy, paste it here, and then provide the path to the work files, the worklet files. So we already know that the worklist file is going to be usernames.txt. Run it, and then let it run for a few minutes to see if we get any results. In the meantime, let's continue with the reading. You provide your current AWS account ID, but this approach would work even if you were scanning a different account. Okay, so this it can be this account ID, it can be any account ID that we have. Alright, now that you've provided your work list, press enter, wait for the scan to conclude. You can expect a scan with this many options to take about 3 to 10 minutes depending on the variety of the factors, including network latency and potential API throttling by AWS. Okay. As you can see, we were successful in identifying any rows in the scan. Oh, so there's none. Maybe Best Cloud Company implements IAM users instead. Try it for yourself. After running the quite right scan at second time with the scan type 2 selected, did you identify any IAM users? Okay, so let's cancel this one. We know that it's not going to give any results. So run it again, quite right. Wait, so before we get into that, let's see what scan 5 does. So scan, what type of scan did you want to attempt? Enter the scan type at 5 example. So number 1 is AWS account IDs, number 2 is Microsoft 365 domains, number 3 is AWS service footprinting, 4 is AWS root user email address, 5 is AWS IAM Principals. And because we were enumerating IAM Principals, so we chose number 5 right here. And then within number 5 we have 2 options, either IAM roles or IAM users. And we had already started with the IAM roles, which we were told that there would be no results. So we're going to try the second option, which is IAM users, to see if we can get anything. Okay. Clear, quiet, right, scan 5, and then the type is going to be 2. Account ID is going to be this one, and then the name is usernames.txt. Okay, in the meantime, let's get going. Let's continue with the reading. Moving on to the next one, enumerating. You know what? You can just wait for a few seconds, a few minutes for it to run, but I've already did it. So this is the results I have right here. As you can see, everything is set up like the way exactly where we just run. The type scan is 2. The ID AWS account is right here, and then the path to the work file is the pre-generated usernames. So when I was attempting this lab the first time, I was downloading from this URL right here. So the name is the pre-generated usernames.txt, but it's going to be the same thing. The content is going to be the same. After scanning for a while, for a few minutes, we got 2 IAM users, John Cervantes and Adam Foreman. So what is John's username? John Cervantes. Is that how you say the name? Last name? I think so. Again, we have to document everything we find. What is Adam last name? Foreman. Okay, S3 bucket is already there with this name, quite right. Okay, download the scan here. So quite right also provide you an S3 bucket with the scan summary and with scan results, which is convenient if you have access to those, and then you can easily view them on the web view. Alright, let's continue with the next task, enumerating root user email addresses. We mentioned earlier in this room that resource-based policies could only return IAM users, IAM roles, and AWS account IDs. Well, that isn't completely true. There's one exception. When using legacy AWS S3 ACL's access control list, now deprecated by default, you can use the ACL policy to place email addresses that correspond to a potential root user email addresses. These root users are particularly interesting as an attacker because they have full permissions against the AWS account, unless otherwise restricted by the AWS service control policy. As an attacker, if you take over a root user account, you have the proverbial keys to the kingdom. QuiteRight supports scanning for root user email addresses, though this technique is inherently slower because it's only supported by the S3 service and is prone to rate limiting. Let's try Adam and John's IAM users as potential root users. We found them as a regular IAM users in the task. After all, we'll create a new file called the root user.txt and add each potential email username to a new line, then run the QuiteRight. Okay, as we have explored earlier, QuiteRight scan number 4 is scanning the root user email. We can double check by running help. QuiteRight has a feature where it will help you generate email addresses based on a provided domain. While our scenario of checking 2 addresses doesn't require such capability, it is useful for if you have a large list of valid usernames. In fact, QuiteRight also supports options for generating a list of almost 2 million potential usernames with common patterns, using common US names, but this time we'll submit only our custom word list, which is the root user.txt right here. Now, again, as you can see right here, scan number 4 is scanning for AWS root user email address. Alright, so this is the command we are going to use. And then what else? Well, it looks like neither Adam or John are administrators. Unfortunately, due to the sensitivity of AWS root user email addresses, we aren't going to be providing a valid email address for this room. Okay, so this is only just a concept. We know what to do, but we're not going to be performing any exercise on this one. However, QuiteRight supports validating email users in Office 365 and G Suite, the 2 most common enterprise email providers. That means you can create potential user lists, validate the emails against the Microsoft or Google tenants, and then run large lists of valid emails against AWS for root user email validation. You might be surprised by what you can find. Okay, cool. What type of the S3 policy allows you to enumerate root user email address? Is it SCP? No. No. ACL. Access control list. Okay, last one. Footprinting AWS services in use. The last concept we're going to cover for IAM enumeration is a little bit different than identifying potential principals to attack or take over. That is because it isn't just human that utilize IAM roles. No, AWS services also take advantage of the AWS IAM role concept in order to perform automations on your organization's behalf. In fact, if you have any service configured to do anything automatically on your behalf or in AWS, author someone or automation ran by someone enable an AWS service role that is being used to perform the actions on the service behalf. You see, even AWS services need permission to perform actions in your account. It isn't uncommon to see an IAM assumed role trust policy with a similar structure though, the following: principal and then the service name and then lambda Amazon AWS.com. Okay. This demonstrates a particular AWS service has the ability to assume the role defined. In this case, the AWS Lambda service can assume the role with whatever permissions are applied. It turns out that this can be really useful when trying to do a reconnaissance against an organization. You see, AWS uses predefined AWS service role names that can be used to identify common services and, notably, security services such as guard duty. If you know a particular account you want to check enable service against, you can run the following QuiteRight command. Okay, again, let's double check QuiteRight S3. And then we're going to provide the no, not this one, the account ID. And we already see a lot of services available running in this account. Scan summary. Number of identified valid principals 6. Number of scan principals 2. Okay, that's a lot. Valid principal, oh, percentage. Okay, so we have 1, 2, 3, 4, 5, 6. We have 6 principals. Okay, what services do you see enabled in the account? How might it change your actions regarding an access key you might find? With guard duty in particular, you know that there are specific security alerts that may be triggered by actions in the account. One special note is that these accounts may continue to be registered in an account, even if an organization discontinues its use. Therefore, it's important to understand that a role assistant isn't 100% accurate regarding the current service use. Okay, so how many roles? Quite right, identified in the account when running service footprinting? 6 roles. What? Okay, hold on. We have 6 valid principals. How many rows? Okay. Wait a minute. 1, 2, 3, 4, 5. Okay, only 5 of them are AWS service role. So 5. Yep. So 5 of them is AWS service role, and 1 of them is organization's account access role, which is completely different. What services appear to be enabled based on the results? Okay, so based on these 6 principles, how do we know which one is enabled, which one is disabled? Well, I'm not sure how to do it on command line. So after doing some research, I came up with a solution is to visit the console and visit each of the service to see which one is configured and which one is not. So let's try with the guard duty first. Right here, as you can see that we have the overview here, we have everything set up, configured, meaning that this is enabled. So we're good. The next one is trusted advisor, right? Support. So this one also looks like that it's been configured and then enabled. Billing, account, everything. So I would say it's enabled to trusted advisor. Let's try that. Check summary action recommended info. Alright, it looks like this one is also enabled. Okay. Organizations. There's no organizations. Can we create one? AWS or yeah, it should be this one, AWS organizations. Doesn't seem to have anything, but it's got details right here, everything. So I guess this one is also enabled. Trusted advisor, and then this one is happening. Route 53 resolver. 53 resolver. Oh, okay. So it looks like this one hasn't been configured yet. And because this one looks the most suspicious, I would say this one is not enabled. So that's my best guess that Route 53 resolver wasn't enabled. It's one of the services that's not enabled. So the answer is going to be guard duty. Second one is organization. Next one is support, and the last one is trusted advisor. Correct? Yes, it's correct. Okay, so that's how I found out that Route 53 resolver wasn't enabled. But I really want to find out the way how to figure out which service is enable or disable on using AWS CLI, which I haven't been able to do so. So if you have any questions, so if you know how to do it, please reach out to me and let me know how to do it. I really want to know. All right, that's it for today's video, and thank you very much for watching. I know we struggle a little bit at the end of the video, but hopefully you learned something, and just like me, I learned something new about this. And if you love watching me struggle, suffer in these activities, in these rooms, please continue watching my other videos. Thank you very much, and I'll see you next time. Bye.